A recent example: the Venice 2019 flood and Mediterranean cyclones. In 2019, a sequence of adverse weather and marine events hit the city of Venice and its lagoon with a frequency and intensity never seen in past years. Sea level has been measured in Venice since 1872, and the exceptional year of 2019 was characterized by 28 high water events, 15 of which occurred in November, where the sea level exceeded 110 centimeters above the official reference level. The second highest year for such events was 2010 with 18 events. November 2019 in particular was exceptional, with 3 events where the sea level exceeded the reference level by at least 150 centimeters in just 6 days. Never in the last 150 years has more than one event of this magnitude occurred in the same year. The sea level remained above 110 centimeters for about 50 hours in November alone in 2019. By comparison, in the entire year of 2012, the year with the second longest period of sea levels above this threshold, sea level remained above 110 centimeters for a total of just 24 hours. Statistical analyses conducted on historical series show how the exceptional events of November 2019 should be placed in a long-term context, characterized in recent decades by a progressive increase in mean sea level and extreme high water phenomena in Venice. With the rise of the relative sea level, a result of both eustachy, the elevation of the sea level, and subsidence of the city itself as it slowly sinks, even minor events are now sufficient to cause flooding in the city. On the 12th of November 2019, an exceptional high water event of 189 centimeters, second only to the infamous event of the 4th of November 1966 at 194 centimeters, led to the flooding of almost 90% of the city. This event was accompanied by the unique presence of a strong wind with gusts exceeding 100 kilometers per hour. To understand the causes of the Acqua Grande of the 12th of November, it is necessary to reconstruct the meteorological situation of that day, which developed within the framework of the unique situation of the entire month. The atmospheric circulation over the central Mediterranean was characteristic of the autumn period. The deepening of an upper-level trough and the advection of cold air from the north resulted in the formation of a cyclonic circulation between Sardinia and Sicily. This Mediterranean cyclone was responsible for intense southeasterly sirocco wind along the entire axis of the Adriatic Sea. With gusts exceeding 100 kilometers per hour, this wind induced water accumulation in the Gulf of Venice. To compound the situation, winds from the southeast and the upper Ionian Sea obstructed the outflow from the Strait of Otranto, which contributed to maintaining a high average level in the Adriatic basin.
The last flood event that struck Venice in November 2019 was second only to the infamous event of 1966 and was generated by several factors such as the strong sirocco wind, the astronomical tide in phase timing with the peak of the storm surge, but also to a particular meteorological situation. In fact, in addition to a deep low pressure system over the Tyrrhenian Sea, which is quite often happening in this case, a mesoscale, a smaller scale cyclone developed over the central Adriatic Sea and moved northwestward almost parallel to the Italian coast, crossing the Venice lagoon in the evening. The pressure drop experienced in the northern Adriatic area and the fierce wind gust that on the rear of the cyclone produced the worst impact on the city of Venice. This aspect is really important since the presence of the cyclone was critical also in terms of prediction of the event, in particular of the water level in the lagoon. Most of the forecasts issued on that day or even the day before predicted the cyclone, but with some uncertainty in its trajectory. But in this case, even an error of 20 kilometers, which is relatively small from a meteorological perspective, produced large uncertainty in water level prediction. So, a better understanding of processes related to the cyclone development in a complex environment such as the Mediterranean basin is really important and is necessary to attain better forecast, both for meteorology but also in turn for the sea state condition of these extreme events.
However, the 12th of November event was also particularly intense due to the combination of two other factors. First, the in-phase timing between the peak of the atmospheric surge and the lower high astronomical tide, and second, the passage of a small-scale Mediterranean cyclone over the North Adriatic Sea. This cyclone moved northward, almost parallel to the Italian coast, and created a meteo tsunami just offshore from Venice and propagated into the lagoon. The sudden, fierce westerly wind from the rear of the cyclone produced a further increase in the sea level as it pushed water against the southern side of Venice, where St. Mark's Square and its historic promenade are located. The correct forecast of the cyclone trajectory across the Venice lagoon was critical for predicting the impacts on the city.
The historical city of Venice is frequently exposed to floods, locally called acqua alta, and represent a front-runner study site for coastal flooding because it has a long-lasting record of sea level observation since 1872. The frequency of flood events increased over time and is likely to increase in the future, mainly due to sea level rise and subsidence. To safeguard the city, an extensive flood protection plan based on the Mose Barrier has been designed and will be fully functional by the end of the year. The 12 November 2019 devastating flood in the city of Venice stimulated new investigation of the coastal flooding problem from different perspectives and time scale. The extreme sea level recorded in Venice was due to a combination of several large-scale and local dynamics. Among these, a fast-moving mesoscale cyclone traveling over the Adriatic Sea generated a meteo tsunami and very strong winds over the lagoon of Venice, which led to a rise in water levels and damages to the historical city. However, according to the analysis of the long-term sea level dataset, this mesoscale cyclone represents an extremely rare episode.